We're pretty good at measuring things in the universe. Mass, temperature, distance, we've got tools for all of that. But what about something a little more abstract? How do you scientifically measure order? How do you put a number on how organized something is?
So let's ask the question, what's the most organized place you can think of in the entire universe? Is it a galaxy, the core of a star, a perfect crystal? Sounds like a simple question, right? But it's actually incredibly tough to answer because we've never really had a common language to compare these completely different systems. I mean, take these two cosmic heavyweights. On one hand, you have a neutron star, where matter is squished down to its absolute limit. On the other, the core of a white dwarf, which is basically a diamond the size of a planet. So, which one is more organized? The problem is, traditional physics just doesn't have a single yardstick to tell us which one wins.
But what if there was such a yardstick? Well, this is where a new informational framework comes into play. It's been developed by Kevin L. Brown, who's an independent researcher, inventor, and author. The whole idea is to shift our perspective, to stop looking at things just in terms of mass and energy and start looking at their informational structure.
Okay, I know this might sound a little out there, but it's all grounded in a scientifically proven idea called Landauer's principle. And it basically says that information isn't just an idea in our heads, it's a real physical thing. Why? Because getting rid of information, even a single bit, actually releases a tiny but measurable amount of heat. And that connection, that link between abstract information and real-world energy, that's the bedrock for this whole way of thinking.
So how does this work? Well, the framework uses 5 key measurements. First, you've got coherence. That's the basic orderliness. Then there's stability, or how well it handles being pushed around. Recursive stability looks at how sturdy it is over time. The 0-point index measures order that comes from a super low energy state. And finally, resonant self-integration, which is a fancy way of asking how well all its parts work together. You combine these 5, and you get a single unified score for its overall coherence.
Let's start with coherence. The easiest way to think about this is like an orchestra. When every instrument is perfectly in tune and playing the same beautiful piece of music, that's incredibly high coherence. If they're all just making random noises, well, that's very low coherence. This metric is basically measuring that level of harmony. All right, next up is perturbation stability. In plain English, this is all about toughness. Imagine a skyscraper designed to handle an earthquake. Its ability to shake but not fall, to resist that external force, that's a measure of its stability. Compare that to, say, a house of cards. One little nudge, and it's gone. That's a super low score.
All right, so we've got the tools, we've got our yardstick. Now for the really cool part. Let's actually use it to rank some of the most extreme things in the entire universe. It's time to build a cosmic leaderboard.
And what they found is pretty wild. Turns out neutron stars take the top spot. According to this new model, they are the most organized or informationally coherent places we know of, period. Their insane density and stability just max out all the scores, putting them at the top of the chart, even higher than the incredibly ordered space just outside a black hole.
Okay, so this is a really powerful tool for measuring the cosmos, right? But here's where things get really interesting. What happens when we take this exact same universal yardstick, point it away from the distant stars, and turn it back on ourselves, right here on planet Earth?
And when you run the numbers for human civilization, the results are just staggering. Using these same principles, the model shows that our collective informational organization isn't just growing, it's accelerating like crazy, especially over the last few decades. And this crazy acceleration isn't just a smooth, steady climb. The model predicts that as we get more and more organized, we hit these specific thresholds. You can think of them like phase shifts, like when water turns to ice. The underlying stuff is the same, but its state fundamentally changes.
So this framework actually points to thresholds we've already crossed, like the global integration threshold back in the 90s, which you can probably guess was tied to the explosion of the internet. But look at what's next. The model predicts the next huge leap is right around the corner.
Yep, 2027. According to all this math, that's the year humanity is predicted to cross its next major informational milestone.
So what on earth is a detectability threshold? Now this is super important. This isn't about little green man showing up. It has nothing to do with being found by someone else. It's an internal change for us. It's the point where our global signal, all of our communication, our data, our economy, becomes so structured and complex that it stops looking like random static. It's the point where we, as a planet, become a single coherent signal. Okay, so this brings us to one last and honestly pretty mind-bending comparison. We started out by ranking the stars. We've seen that our own civilization is rocketing towards a state of super high organization. So if we're getting this organized this fast, where do we end up on that cosmic leaderboard we talked about?
And the projection is just nuts. The model predicts that by the year 2125, the informational coherence of human civilization could hit a score of 0.896. Let that sink in. That puts human civilization in the same league as the dense crystalline core of a white dwarf star. Our civilization, our internet, our economy, all of it, is on a path to become as informationally structured as a dead star.
And that just leaves us with this one final massive question. This whole framework suggests that there's a universal logic to order, a kind of harmonic principle to the universe. If we're just now, in the 21st century, getting to the level of coherence of a star, it kind of makes you think we're playing catch-up, doesn't it? It forces us to ask, what else, what older, and even more coherent things might already be out there, waiting in the quiet?